Hello everyone. I just want to show you how to make the equation in Excel, the one related to the gas law and Excel. Here is the way you will do that. I already copy all my volume, the one that I calculate all after cranking the cylinder and the different temperature. So I need to type now the pressure that I go. The first pressure that I go in hectopascal, which is 100 pascal, will be 300 for the first one, negative 250 for the second one, negative 200 for the next one, negative 150, um, negative 50, and then after that it becomes positive 150 the next one, 450, 750, and 1150. So those are the data that I have for the um, calculations that I did, the experiment that I did. So the first thing, the first formula that I need to enter in Excel will be converting the milliliter to liter. How? Let me open the whiteboard that I have right here, and I'm going to get a white page. So you know that 1 liter equal 1,000 milliliter, right? And we have here on the first one, we have 65 milliliter. So we need to place the 55 milliliter here, and we can make a proportion and solving how many liter will be. That will be question mark will be 1 times 65 over 1,000. I'm not going to use the unit in Excel because that will be, it's already posted on top. Going back to Excel, I'm going to do the following: 65 divide 1,000. And then I don't need to do the typing again for the formula. What I can do is dragging all my formula. I click on the right corner and dragging down, and they will calculate all the volume. I still want more to go. Automatically, Excel will calculate the remaining formula, applying the same formula that I placed on the first one. Again, that will be this divided 1,000. The second one will be uh, converting Celsius to Kelvin. And if you remember, the formula will be the following: Kelvin will be equal Celsius degree plus 273. So I need to add 273 to any of these temperature that I have here. So equal to this temperature plus 273, right? And then I'm going to drag all the formula down, so automatically Excel will calculate the formula. The next thing will be converting pressure in hectopascal to pressure in atmosphere. And I had the conversion on the side here. They say 1 hectopascal. Let me use my Excel again, my whiteboard again. They say on the conversion that I found that 1 hectopascal equal to 0.11130986. So if I want to convert negative 30 hectopascal, I need to multiply by that number. My question will be negative 300 hectopascal times the conversion factor 0.00986 divide 1 hectopascal. This is ATM, of course. 1 hectopascal, and these two cancel out, and that's the formula that will go right here. So I'm going to select this pressure and multiply by the factor 0.013 two. Okay, we had three. Yes, 98, six, six. That will be enough. Okay, and that will be my pressure in atmosphere. And I will do the same thing, dragging my formula all the way down, and they automatically calculate the rest. Next thing, I had to divide temperature over volume, and the formula will be, always remember you need to type equal sign, and that will be temperature in Kelvin is this one, right? Because you need to divide in Kelvin. Divide volume, and volume is in liter will be this one, D2. Hit enter, and then I go all this value that you will see in a moment, because I'm going to do the same thing, dragging all this number down, and you go all the volume. Okay, if you want to make a small decimal place or increase, you can do the following, and then they can round it out or making it smaller. So I think I had too many decimal place, so let's do this one. Last but not least will be converting the pressure in absolute value, because you have the pressure here in ATM and there are negative, and on the procedure, on the lab procedure, they say you need to add 1 to that pressure. So I'm going to do the following, this pressure plus 1, and then I hit enter and dragging down, I got this value. Next thing to do is making a graph. How can you make a, a graph? The procedure, the lab procedure explain you that, but this is the way you will do that. Select all the data by dragging the mouse from the top one all the way to the bottom, and then go insert, go to chart, select this one, scatter, and that will be your graph for this experiment. But that's not the end. Okay, let me make bigger. The next thing will be finding the straight line equation. If you remember math, the line a straight line equation will have the following format. It will be y equal a slope times the variable plus the b that will be the intersect. So we need to find the similar equation for this line. So click on any point, doesn't matter. You click any point, right click on the mouse, and then say add trend line, this one. And then they say, the procedure says set the intersect to 0, display equation, and display the r square. And here is my equation. I need to make bigger because it's kind of small. Let me make bigger that one. And that's your the first one, the top one. This one is the line equation for the one that you just add the trend line, and 0.9099 is not the r that you need to report in your calculation. That will give you the correlation factor that you, the closer to the one, the better correlation. So apparently all the points that I calculate are in relative good correlation. Last but not least, you need to use that formula, the one that you go on top, this one. And actually, let me copy and paste on my, let's see if I can copy, maybe, and then I will go to the whiteboard again and see if I can paste here. Yeah. No, it's not pasting, but I can type because it's not like a big deal. It's a small formula. So I'm going to do the following. My y will be 0.001x, and b will be 0 because I set the intersect to 0. So this number will be 0 for my equation, so you don't have anything to add in. And on the procedure, they give you the relationship. They say, okay, y will be your pressure, n, which is this one, will be number of mole time gas constant, and x is T divided by V. So this is the formula, or this is the part that we use the slope to find the R experimentally. How? You have to do the following. R will be equal the slope, which is 0.0001 over N. Where did this is the actual value of R, or the experimental R that you need to calculate. And where do you get then? At the beginning of the experiment, before you start cranking the gas and changing the pressure, the volume and pressure change, at the beginning on second page, they say initial volume of the gas and mole of the gas, the mole that you calculate for the gas. And that's the one that has to go right here. So you use your mole depending on the volume you use, and place that one here, and that will give you the R experimentally. And last but not least, you need to calculate the percent, and the formula is also given on the last page. Percent error will be equal true value, which is 0.082. That's the true value for R. My experimental will be this one, that will be based on your experiment, over the true value, which is 0.082 times 100. And that will give you the percent error that you can get after you perform your experiment. So that's all for using Excel and calculating everything. Remember, this is just a simple sample data. So eventually you may be getting a different value, because not all the experiment will be performing in the same way, because it will depend where do you start or what volume do you use at the beginning. That can make a difference. And that's all, guys. I hope you find this video useful. Thank you for watching.